All right, welcome to 9.2 day 1 video. Today you are going to be looking at addition and subtraction identities, so make sure you have your formula sheet with you and identify where those are and keep that handy as we go through this lesson. We're used to our normal unit circle with the increments, pi over 6, pi over 4, pi over 3, but what we haven't really identified yet is that there are values in between. These red lines on here identify those values in between. This unit circle right here shows those radian values and those angle value measures that are in between that we don't have identified values for yet. Our addition and subtraction identities will help us find those values. Here are addition and subtraction identities. Again, these are on your formula sheet. These identities have a little song that goes along with them, so I will sing that for you, and then you can try and re-listen to it and try and sing along too. Maybe you can sing it for your family members that are at home too. Annoy your siblings with it maybe. So it goes like this. Sine, cosine, cosine, sine, cosine, cosine, sine, 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 tan plus tan over 1. Flip the sine, tan, tan, you're done. Now I know my trig IDs. Work with them to get at least a B. All right, that's enough of that for today. But you can re-listen to that. It's just something to kind of help you remember the rhythm of what the identities for sine are. If it's addition in sine, it stays addition in the identity, and then so forth. If it's subtraction with sine, it stays subtraction in the middle. If you notice cosine, that sign in the middle, positive or negative, flips when you apply the identity. All right, so let's start trying to apply these. We are going to start with an example of sine. So find the exact value for sine of 105 degrees. 105 degrees, if you look at your unit circle, isn't one of the known values that we have. So we're going to have to look in between values. So we're going to have to take 105 degrees and split it up into two angles that we do know. For example, 105 equals 45 plus 60. So we are really identifying or evaluating the sine of 45 degrees plus 60 degrees. And then in our song, the sine comes first. So sine, cosine, cosine, sine. So you do sine of 45, cosine of 60, and then this is plus, so we keep the plus in the middle, cosine of 45 degrees times sine of 60 degrees. Then we look at our unit circle. Sine of 45 degrees is root 2 over 2. Cosine of 60 degrees is 1/2. Plus cosine of 45, which is root 2 over 2, times sine of 60, which is root 3 over 2. So we have root 2 over 4. 2 times 2 is 4. Plus root 6 over 4. And since those have common denominators, we can combine that into one fraction. Root 2 plus root 6 over 4. And we will leave it exact. You don't have to worry about typing it into your calculator. Just leave it in radical form. Next, find the exact value for cosine of 105. So 105 degrees is 60 plus 45 again. So we will do cosine of 60 degrees plus 45 degrees. And since addition is commutative, you could do 45 plus 60 degrees. You would still get the same answer. So for cosine of 60 degrees plus 45, cosine is cosine, cosine, sine, sine, sine. So cosine 60, cosine 45. And then for cosine, remember the sign in the middle changes. So instead of addition, it'll be minus sine of 60 times sine of 45. Then we refer to our unit circle to substitute in those exact values. Cosine of 60 is 1/2. Cosine of 45 is root 2 over 2. Sine of 60 is root 3 over 2. Sine of 45 is root 2 over 2. So we get root 2 over 4 minus root 6 over 4. Common denominators we can combine into one fraction. So root 2 minus root 6 over 4. All right, next, tangent. Tangent is something special. For tangent, we want to avoid the values or the degree measures or the angle measures where your tangent is root 3 over 3. Because then we get, since the identity for tangent is a fraction, then you get fractions within fractions, and then with rationalizing and all of that, it gets very complicated. So we're going to avoid 30 degrees, 150 degrees, 210 degrees, and 330 degrees, just when it comes to tangent. So for this one, for 165 degrees, you might have to think a little bit about this. We're going to use some bigger values. So I'm going to use 120 degrees plus 45 degrees. And those don't fall within those values we want to avoid. So we should be okay. So this is going to be tangent of 120 degrees plus 45 degrees. And then our identity for tangent is tan plus tan over 1. Flip the sign, tan, tan, you're done. So tan of 120 plus tan of 45 over 1 minus, that's the flip the sign, tan 120 times tan 45. And then we just substitute in our values. So tangent of 120 degrees is negative root 3 plus tangent of 45 is 1 over 1 minus negative root 3 times 1. So we get negative root 3 plus 1 over 1 minus negative root 3, so 1 plus root 3. Now, normally we ask you to rationalize these. So in this case, we would have to rationalize by multiplying by the conjugate of the denominator because it just simplifies it a little more. But just because of where we're at, let's keep this simple. And I'm just going to leave this as 1 minus root 3 over 1 plus root 3. So here on forward, don't worry as much about rationalizing. I just want to know that you know how to use the identities at this point. All right, now we can also use these for radian measures. So remember, some helpful values to get to know are going to be the simplified versions and then the unreduced versions of these fractions. So pi over 6 is equal to 2 pi over 12, pi over 4 is equal to 3 pi over 12, and so on and so forth. You can see with those other values. The reason those are going to get pi over 12, notice that's not a value we know on our unit circle. So to get pi over 12, we're going to have to subtract some values. You could do 3 pi over 12 minus 2 pi over 12, or 4 pi over 12 minus 3 pi over 12. I'm going to just take 3 pi over 12 minus 2 pi over 12. Helpful is if you can see in this first example here, find the exact value of sine of pi over 12. Well, so for sine pi over 12 is equivalent to 3 pi over 12 minus 2 pi over 12. All right, if we simplify or reduce those fractions, you get sine of pi over 4 minus pi over 6. So now for this, we use the subtraction identity. So sine, cosine, cosine, sine. So sine of pi over 4 times cosine of pi over 6. This is minus, so we're going to do minus in the middle. Cosine pi over 4 times sine of pi over 6. Sine of pi over 4 is root 2 over 2. Cosine of pi over 6 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. Sine of pi over 6 is 1/2. Multiply root 6 over 4 minus root 2 over 4. Common denominator, so you can combine it into 1. Root 6 minus root 2 over 4. All right, if you look at this one, notice this is cotangent, so now we're dealing with reciprocals. So cotangent of 7 pi over 12 is going to be equivalent to 1 over tangent of 7 pi over 12. So what we're going to do, there's multiple different ways you can do this. The way I like to do it is figure out what my tangent of 7 pi over 12 is, and then whatever I get for my fraction for that, just find the reciprocal. So tangent of pi over 12. Now remember, there's values we want to try and avoid. So with this one, we're going to want to avoid pi over 6 in radians, 5 pi over 6 in radians, 7 pi over 6, and 11 pi over 6. Okay, so make sure we avoid those values because that's where tangent is root 3 over 3. So pi over 12, it looks like we should be able to do then the 3 pi over 12 and 4 pi over 12. So we are going to do tangent of 4 pi over 12 minus 3 pi over 12. 4 pi over 12 minus 3 pi over 12 is 1 pi over 12. So simplify those, reduce those fractions. You get pi over 3 minus pi over 4. And then the identity for tangent, if it's subtraction, it's going to be tan minus tan over 1. Flip the sign, tan, tan. You're done. So for this one, we're going to have tangent of pi over 3 minus tangent of pi over 4 all over 1 plus, you want to flip that sign, tan of pi over 3 times tan of pi over 4. Use our unit circle to fill in those values. Tangent of pi over 3 is positive square root 3 minus tangent of pi over 4 is 1 all over 1 plus root 3 times 1. So now remember, this expression represents tangent. We want 1 over tangent. So what we're going to do to this then, to get cotangent, is just flip it, because remember, cotangent is the reciprocal of tangent. So cotangent of 7 pi over 12 equals 1 plus root 3 over root 3 minus 1. And again, we don't have to worry about rationalizing. Let's just make sure we know how to use the identities for now. All right, so that should pretty much cover what you need to know in applying or using those identities. Don't forget to do your daily task on Schoology. And then there is a 9.2 worksheet with an answer key on there. It's not graded, but it's good for extra practice. So if there were any examples on here you didn't get, maybe retry them on your own and then see if you can find any that are like that on the worksheet. All right, see you tomorrow.